This is Professor Thompson, and I'm going to do some problems from 5.3. I'm going to just do some of the more difficult integrals first. And this is 13. And they're just trying to trick you here because they have x over 2 and then 2 over x. And so remember, x over 2, that's just a half times x to the 1. So I'm going to use the power rule and make that x squared over 2 times a half, so really just x squared over 4. And then when I do 2 over x, just think of 1 over x by itself, which that's a special case where the antiderivative is ln x, and then you still have the factor of 2. So now I plug in 2 and I plug in 1. And you want to make sure that if you plug in 2, so here I have f of 2, subtract all of plugging in 1. So use parentheses there just in case. And so here I get 1 minus ln 2, and then when I subtract I get a fourth minus 2 ln 1. Now, ln of 1 is 0, so I don't really need that guy. So it's 1 minus a fourth, which is 3/4, and then minus ln 2. So this is our exact answer right here. Alright, the next one I am going to do is 21. And so in general, we can't really do fractions, but in specific cases we can. So this is dr over square root of 1 minus r squared from 0 to square root of 3 over 2. And the way to recognize this is to think about the drs elsewhere and think about 1 over square root of 1 minus r squared. Now you should recognize it as the derivative of arc sine r, and I'm going to plug in square root of 3 over 2 and then subtract plugging in 0. So when you think about what number in the range of arc sine had sine square root of 3 over 2, that would be 60 degrees, or pi over 3, and then arc sine of 0 is 0. So here you get pi over 3. This next one is 25, and so we're going to use a trick about rules for exponents. Here, this is e to the u plus 1 du, but the only rule we have for e is that we know e to the u is derivative. So when I write this using exponent rules, is e to the u times e. And e is a constant, so I'll just bring it out of the integral because we have that rule for integrals. And e to the u is its own antiderivative. So this would be e times e to the u evaluated at 1, and then subtract evaluated at minus 1, and then you multiply by e. So that would then be e times e minus e to the minus 1. So I guess that's e squared minus 1. The way I got the 1 was that e to the 1 times e to the minus 1 is e to the 0, which is 1. So now I would like to do a problem involving absolute value. So this is 28. And this is the integral from 0 to 2x minus 1. So the way that we can work with absolute value is that it's a piecewise function, and we can split integrals into pieces. So we have to think about, where does the definition of absolute value change? Well, it depends on when the expression inside the absolute value is positive or negative, because if the expression is negative, then the absolute value is going to flip it with a negative. Otherwise, it's going to leave it the same. If I solve that equation, I get x is greater than 1/2. So that means that if I go from 0 to 1/2, I have one expression. And if I go from 1/2 to 2, I have another expression. And what's inside the absolute value there, we've proven is positive when x is greater than 1/2. So in that piece, we don't even need the absolute value. However, over here, I basically just need to multiply by a -1 because that's what the absolute value is doing. And so now on the next slide, I will evaluate both these integrals separately, and then I'll add them together. So I guess we'll call them a and b. So first let's do integral a, which is 0 to 1/2, 1 minus 2x. When you integrate, you get x minus x squared. Plug in 1/2 and then plug in 0. So that'll give you 1/2 minus a fourth minus 0 squared. And all that together is going to be 1/4. Now when we do integral b, it's just 2x minus 1 from 1/2 to 2 dx. So that'll be x squared minus x. And we'll plug in 2, and then we'll subtract plugging in 1/2. Now again, be careful. Make sure that you put parentheses around plugging in 2 and then plugging in 1/2. So this will be 4 minus 2 minus 1/4 minus 1/2. So that's 2 plus 1/4. So here I got 2 1/4. When I add those together here, these two answers, the final answer comes out to be 2 1/2. Now the last one I want to do is an application here, and this is number 33. And so they just say find the area of the region that lies under the curve y equals 1 minus x squared and above the x-axis, which is y equals 0. Well, I have to figure out where they intersect to do that. And that means asking when 1 minus x squared is equal to 0. And that happens when x is plus or minus 1. So if you think about this graph, it's negative x squared shifted up 1. So it looks like this. And right here, this is the area that they're talking about. So that means that I can use minus 1 and 1 as my limits of integration, because they're talking about the integral in that region specifically. And so that integral then is x minus x cubed over 3. Plug in 1, then subtract plugging in minus 1. And I get 1 minus a third minus 1 plus a third. So altogether I get 2/3 plus 2/3. So I get 4/3 altogether. And that's it for 5-3.